Hi, folks. Today we're going to take a look at this supplemental lesson number 2. We're going to look at something called Euler's method. Okay, it's not pronounced Euler's method. It is pronounced Euler's method. So just keep that in mind when you're watching other videos. They're going to say Euler's method. Okay, so skills to master. In this section, what we really want to do is think about we've only learned two types of solutions for differential equations. Like we've learned how to solve a differential equation that is separable, where we sort of clump all the x dx's on one side and all the y dy's on one side, and then we can sort of integrate each side. And then we've also learned how to solve a first order linear differential equation. But beyond that, there's good news, bad news. There's actually a lot of different types of differential equations. And so one of the things that it turns out is that some of these differential equations have really complicated solutions. And when we run into this idea of really complicated solutions, Euler actually came up with a way to approximate a solution. So using the idea of having a bunch of straight lines, we can get close to what a curve would actually give us as an exact value. And this is what we call an approximate solution. So it's not the actual solution, but it's an approximate solution. And sometimes the approximate solution is actually good enough. Okay, so in this video, we're going to take a look at two examples where we walk through this process of Euler's method and that we think about like, what is it that we're finding? Okay. All right, let's get started. So example 1, consider y prime plus 2y equals 2 minus e to the negative 4t and the initial conditions y of 0 equals 1. Okay, so I just want to remind us, we've been talking about this idea of initial conditions. And this y of 0 equals 1 really means 0 comma 1 is a point on our solution curve. Okay, so this statement says use Euler's method with a step size of 0.5 to find the approximate value of the solution at y of 1. Okay, so I'm actually going to draw a little graph right here so that we can kind of keep track of what we're finding along the way. All right, it'll also give us a little bit of a path towards getting to our solution. Okay, so the first thing I'm going to put on here is my initial condition. I know that at x equals 0, y equals 1. So this is my point, 0 comma 1. Okay. Now, we're using a step size of 0.5, and ultimately we want to get to an x value of 1. So what does that mean? That means we can take one step, and that'll get us to 0.5. And if we take a second step, that'll get us to 1. Okay, so we're going to have to take two steps of 0.5 to get to 1. And once we've gone through this process twice, we'll end up with our approximate solution. Okay, so let's take a look at how we get started. All right, so I'll put this over here. Step number 1. Okay. I like to go ahead and write out all of my information. So maybe let me actually put that next to the graph. All right, so all of my information, I like to collect it all in one place. And what I mean by that is I'm going to take my y prime equation, and I'm actually going to get y prime on one side all by itself. So in this case, the only thing I need to do is move this 2y to the right-hand side. So I'm going to get y prime equals 2 minus e to the negative 4t minus 2y. Okay, so I've taken my differential equation and all I've done is get the y prime all by itself. The next thing I like to write down is my initial condition. So I also know that we're going to call them x0, y0. Okay, that's our way of saying this is where we're starting from. My x0, y0 is 0, comma 1. Okay? And then the last piece of information that I like to put down for myself is what is my step size? So my step size, h, is 0.5. Okay? Now, I would say this step is probably optional. If you're like, I can see all the information in the question, Judy, I don't need to write it down, that's fine. But if you're someone who likes to keep your work a little bit more organized, this might be a nice place. So you have like your diagram and you have your information right there. All right. So as we said earlier, if we're starting at x equals 0, it's going to take us 2 steps to get to 1. Okay, so what we're going to do in step 2 will get us to 0.5. And then what we do in step number 3 will get us to 1. Okay, all right. So this gets to go from x equals 0 to x equals 0, 0.5. Okay, so this is what we would consider our first step. All right, here's what I'm going to do. I'm going to write up a equation that maybe seems familiar for us. This is our point-slope equation of a line. Okay, so the point-slope equation of the line is y minus y1 equals m parentheses x minus x1. Okay, this is the equation of a line. And all we need to write this equation is the slope and a point on the line. Okay, so we're gonna move some things around and we're going to change what letters we use to talk about a specific thing. Okay, so what I mean by that is instead of x1, y1, I'm going to change it to x0, y0, because this is where I'm starting from. Okay. The other thing that we're going to do is we're going to change our m to be our y prime. Okay, so if you think all the way back to your Calc 1 days, anytime you were thinking about a derivative, what you were actually finding was the slope. Okay, so maybe we color code that for ourselves. This y prime is the same as our m. Okay, and so here's how I'm going to write it. I'm going to make this y minus y0 equals y prime of x0, y0 times x minus x0. And so it looks a little bit longer, but this m is the same as y prime of x0, y0. Okay? And now I'm going to do one last algebraic piece. I'm going to move this y prime to the right-hand side. So in other words, I want to get y equals something, something, something. Okay? So what does that give me? I get y equals y prime of x0, y0 times x minus x0 plus whatever my y0 is. Okay. Now this is going to be a single number. I know this looks like a lot of letters, but it's actually just one number because it's the slope at that point. Okay. Meanwhile, my x0, let's go back a little bit. My x0 is 0, and my y0 is 1. Okay, so I'm going to be filling in the green, the yellow, and the blue. All right, so let's find some of this information off to the side. In particular, I'm going to find y prime of x0, y0 off to the side. Okay, so all I'm going to do, I'm going to take my y prime equation, and everywhere I see an x, I'm going to put the 0, and everywhere I see a y, I'm going to put a 1. Okay, and I just realized that I'm using a t here. So t usually in the same place as x. So what this really means is that for my 0, I'm going to put it in for the t value. Okay, So let's see what we get. 2 minus e to the negative 4 times 0 minus 2 times 1. Okay, we'll use our calculator and we'll find that we get 2 minus e to the 0 minus 2. And hopefully remember that e to the 0 is not 0, but it's 1. And so what we really have is 2 minus 1 minus 2, which gives us negative 1. Okay? And so what that means is the slope of this graph at the point 0, 1 is negative 1. That is what I get to plug in right here. And so I'm going to have y equals negative 1 times x minus 0 plus 1. Okay, so this is my slope, this is my x0, and this is my y0. All right, now this is going to give me a more simple equation. Y equals negative 1 times x plus 1. Okay, now we are almost done. The last thing we have to do is think about how big our step is. All right, so I'm going from 0 to 0.5. What that means is my x is 0.5, right? It's like the next step over. So we'll make that one last substitution and we'll get y equals negative 1 times 0.5 plus 1. And if we work that all out, we should get 0.5. Okay, so here's what this means. I get an x value of 0.5 and a y value of 0.5. This is what we call our x1, and this one is our y1. Okay. Now, what is this x1, y1? If we go back to our graph for a moment, it means that at the x value of 0.5, that the y value is estimated to be 0.5 as well. Okay, so this is a 0.5, 0.5, and that is just an estimate. So it's not an exact solution, but we're saying if we use the idea of a straight line, then our estimated solution here is 0.5. Okay. Now, we've only gone from 0 to 0.5. We still have to go one more to get to 1. Okay. So what we're going to do is we are going to repeat this process for number 2, but we're going to now go from 0.5, 0.5 to our new point at x equals 1. Okay. All right, so let's write that out. And this is going to take us to go from x equals 0.5 to x equals 1. Okay. All right, so we're going to start with this line right here. We're going to use the same idea of a straight line, but I'm going to change some of the numbers here, okay? So instead of having y0 and x0, I'm actually going to have y1 and x1. And the same thing here, this will be x1 and y1, okay? The other change that we're going to make is instead of this just being a y and this being an x, we're actually going to call this y2 and x2. Okay, so now we've moved from like going from x0, y0 to x1, y1, and now we're going from x1, y1 to x2, y2. Okay. All right, so we've got y2 minus y1 equals y prime of x1, y1 times x2 minus x1. All right. Now, usually people go ahead and already add the y1 to the other side, so they don't have to do it later, but I'll leave that up to you which way you prefer. Okay. So I'm going to do it right now. y2 equals y prime, x1, y1 times x2 minus y, x1 plus y. Okay, now we already have a lot of this information, okay? So our x1 is 0.5 and our y1 is 0.5, okay? So those things I can fill in. I also know that my x2 is going to be 1, all right? So I've got y2 equals y prime of 0.5, 0.5 times 1 minus 0.5 plus 0.5. Okay? Now, just like before, this y prime of 0.5, 0.5 is actually just a single number. It is a slope at that point. And how do we find the slope? We plug it into our y prime equation. Okay? So let's do that work off to the side. I've got y prime of 0.5, 0.5 equals 2 minus e to the negative 4 times 0.5 minus 2 times 0.5. Okay, so if you compare this to the previous step, all I've done is just plug in different numbers in for the slope. All right, so let's use our calculator. Let's see what we get. We get 2 minus e to the negative 2 minus 1. Okay, and all of this is going to go in for my slope. Like all of that is just a single number. Okay. Now, I'll leave the calculations up to you, but when I plugged in everything, I got 0.9323 for my y2 value, okay? And what that means is that 1 comma 0.9323 is the approximate solution. So 0.9323 is our linear approximation for an answer at x equals 1, okay? So let's go back to our graph for a moment. Let's see, where would we put this? So at 1, and we're going almost up to 1, so 1 comma 0.9323. This is our approximate solution. Okay, so let me zoom out for a moment. We'll get this all on one page for you. All right, so I'll have you take a look at that. My advice would be to go ahead and try example number 2. I'm going to post that in a separate video, but go ahead and try number 2 using this, and then you can go watch that video and see if it matches with what you have. Okay, I'll see you back here in a bit.